Hey, so in this video I want to talk about how we can pass pointers to a function. We've talked about value parameters previously, we've talked about reference parameters. Now here we'll need pointer parameters. So we can declare pointer parameters in the formal parameters of a function. You can see we have void print. So in this function we'll just print the integer that the pointer parameter will point at. Now in the function call, the argument can be a pointer or an address. That is using the address of operator. You can see in the examples here, so I do print, and then I pass in an address using the address of operator. I pass in some integer, then I do print again, and in this case I pass in a pointer, some pointer to an integer, and in both cases the local variable in the function, which in this case is a pointer, will be initialized to the address that we pass in, or to the address that the pointer contains that we pass in. Okay, I have a quick example. I have this function called increment score, and in this case I just have a value parameter int x. I increment x and I print it out. I'll just create a variable in main called score and I set that to 5. So let's say we have some game and we pick up coins, and each time we pick up a coin, of course we want to simply go and increment our current score. So let's call that function, and I'll pass in score. And then I'll print out score once again. Build around that. We'll get more or less what you would expect at this point. We get 6 printed out in the function. So we pass in 5. That gets incremented to 6. But then back in the main function, we print out 5. So once we pop that stack frame off of the stack, the local variables are removed. We don't return that variable or anything like that. You can do int here maybe, and then set score equal to whatever this returns if you want. In that case maybe we'll return x, but the point here is it doesn't affect the value that you pass in to the value in the calling function. Alright, so what we can do is you can do a reference. So we've talked about references before. Now if I build and run this, then you'll get 6 and 6 printed out. So in this case, x in this increment score function is just a reference or another name for this score or whatever it is that we pass into the function. So if you increment it or change it, that's going to reflect in the calling function, and that's why we get 6 printed out here and in the main function as well. Okay, so but how can we do this with pointers? If I change that to a pointer, now what we can do is we can pass in the address. So the address of score, but you'll notice a problem here. We do x++. And if you remember from the sections on pointers, this is an offset notation for the pointer itself. You want to actually change what it is that you're pointing at, meaning that you want to do a dereference first. Now another thing to note is that the ++ has a higher precedence than the asterisk or the dereferencing. So you want to use parentheses or those brackets to make sure the dereferencing happens first before you do the increment. This will mean that we'll go and fetch whatever that pointer is pointing at, in this case the score variable, because we've passed in the address of that score variable, which this pointer will now contain. So we fetch that score variable, then we go and increment that score variable. And how do we print this out? This will actually print out the address, so we want to dereference that. And we can build and run, and you'll see you get 6 and 6 printed out. Of course we can do a pointer as well. So we'll simply pass in a pointer to an integer which points at the score variable. And you'll see that works as we would expect as well. It's important to remember the const qualifier and how we qualify pointers. And just to reiterate this, I'll just duplicate that function because it already has most of the functionality that we need. And what I want to create is a simple function called print score, and this will also have a pointer parameter. Now all we want to do in this function is we want to print something out, so we don't actually want to make a change to whatever it is that we pass in. You can decide to change the variable name if you want. For this I'll just leave it as is. So what we have in the parameter now is a constant pointer to a constant integer, and of course that means that we cannot change the pointer to point to something else. And we can also not change the variable. We cannot go and fetch that and then change it or set it to something else. We've talked about that in a previous lecture on pointer qualifications and how to use the const for that. So that should allow us to print out a pointer to an integer that we pass in, or if we give it an address to some integer. Here, for example, we can do something like this. If we build and run, that should work fine. If you want, you can go and pass in the pointer here as well, as I demonstrated previously. So next I want to qualify this pointer parameter, and it's not going to be exactly the same as this one. So I'd like you to, as an exercise, think about how we are going to qualify this parameter. And when I come back, I'll show you what I would do and how I would qualify that parameter. Of course, with the increment score function, we do want to change. So not the address where the pointer is pointing, but we actually want to fetch the variable or the object that the pointer is pointing at in memory. In this case, it will be the score variable, and then we want to increment it. So in other words, we don't want to offset or change the pointer itself. We just want to change the variable that it is pointing at. So that means we cannot do a pointer to an integer constant, because in that case we'll get an error. Expression must be a modifiable L value. We don't want to set the pointer itself to point to something else. So that is why this here is how I'll qualify this parameter. X is a constant pointer to an integer. Build and run that, and we should get 6 and 6 printed out. That works fine. Alright, let's go and remove those brackets now. Remember I talked about those brackets previously. Expression must be modifiable L value. That changed because the pointer is now const. And I talked about how we are trying to change the pointer, so to set the pointer to point to something else. Say no. You see here we get an error, X. You cannot assign to a variable that is const. So here it is clear that we are actually trying to change X instead of dereferencing X and changing the variable that it points at. That is once again why you use the brackets, to ensure that you do the dereferencing first and then the increment. Alright, so in an upcoming lecture we'll also talk about how we can return pointers from a function, and that means in the function body maybe you can create a dynamic variable and return a pointer to that back to the calling function. So maybe think about how you think you would do that, and if you play around with it for a bit you'll actually see it's not that difficult. You might be able to figure it out by yourself at this point. Alright, that is going to wrap up this video. I'll see you next time.